Ka into Kb is equal to Kw is valid for, there is an expression that's given Ka into Kb that's equal to Kw. You should always remember that this expression is only valid for the pair of conjugate acid and conjugate base. Let's check HCl and NaOH. These are not the pair of conjugate acid and base. Then ammonium hydroxide and formic acid. These are also not the pair of the conjugate acid and base. Let's check the next one. HCOOH, formic acid, and HCOO negative, the pair of conjugate acid and base it is, and that's why this expression is valid for this, and I'll choose it as the correct option because of the same reason, that is here. Now after this, let's take next question.
Now question number 82. The solubility of AgCN in 0.02 molar KCN solution, assuming no complex formation, is. Ksp value for AgCN is given, that is 1 into 10 to the power minus 16. So here we have to just find out the solubility of this AgCN in KCN solution. So if we talk about this AgCN, this is silver cyanide, in solution, dissociate into ions in this way, and let's assume the solubility is S. For these ions we have assumed. Similarly, KCN is also present there. That's a strong electrolyte. It gets dissociated into ions. And one more thing, we know the concentration of this solution, that is 0.02 molar solution. So in this case, we just have to consider that the amount of this potassium ion is 0.02 molar. Similarly, if we talk about the CN, this is also 0.02 molar. Now, we have the concentration of this. Now, we know that Ksp value for AgCN, we are just going to calculate the solubility of Ag ion, Ag positive ion we have. The solubility of CN ion is S also, but this is also present there due to KCN also. That's why the total concentration we will take S plus 0.02. Now, in this case, this Ksp value that's given in the question, 1 into 10 to the power minus 16. In presence of common ion, the solubility of the salt decreases. It means the value of this S squared would be very less. Due to the presence of common ion, the solubility of the salt is reduced, and that is why the product of this S squared is very low, or we can simply write it as, this product can be written as 0.02 S. Now the solubility S would be equal to 1 into 10 to the power minus 16 would be divided by 0.02. And if you solve this value, you will find out that this is 5 into 10 raised to the power minus 15 molar. This would be the value. And this value is given here in question number 3. That's why I'll choose it as the correct answer. This is the correct answer for my question. Now, after this, let's take next question. Question number 83. On mixing equal volumes of the following solutions, precipitation of AgCl will occur in. Ksp value is also given, and we should always know that whenever we talk about the precipitation, that occurs when the ionic product is more than solubility product, that's Ksp value. Now we have to just find out this. So in first case, we have 2 into 10 to the power minus 4 molar Ag positive ions in the first option it's given, and 10 to the power minus 6 molar Cl negative ion. Let's find out the ionic product for the first case. Ionic product you're just going to find out, and here it would be 2 into 10 to the power minus 4 into 10 to the power minus 6 divided by 2. So this would be the ionic product, and if you solve this, you will find out that value is 0.5 into 10 to the power minus 10. This is the ionic product. Now let's check the second one. The ionic product for the second case is 10 to the power minus 5 molar is the amount of Ag positive ion, and now let's multiply it, 2 into 10 to the power minus 5 divided by 2. So the ionic product for these two would be 0.5 into 10 to the power minus 10. This is the ionic product for the second case. In the third option, the third case is given, where 10 to the power minus 4 molar Ag positive ion and 10 to the power minus 4 molar Cl negative ion, means equal molar concentration of these two ions are taken. So 10 to the power minus 4 divided by 2 into 10 raised to the power minus 4 for the Cl negative ion. And the ionic product would be equal to, if you solve this, you will find out this is 1 by 4 into 10 to the power minus 8. Or simply you can say 25 into 10 raised to the power minus 10. This would be the value. Now you can easily compare this with the KSP value. If you look at these values, you will identify that the value that's given here, this 25 into 10 raised to the power minus 10, is more than that of this KSP value. What's that? This is 1 into 10 raised to the power minus 10. So on that basis, the third case is the case when mixing these two solutions, precipitation will occur. And definitely this is the correct answer. And that's why I'll write here it as the correct one. Now, after this, let's move on to the next question. Question number 84. Number of buffers can be made by the reaction of H3PO4 and NaOH. We have a weak acid, we have a strong base. And if you mix these two, in that case, there is the formation of the salt of a weak acid and a strong base. It means in this case, you will get a mixture of a weak acid and the salt of that weak acid with a strong base. That you will obtain. And if you will obtain that, it means buffer is formed and that buffer is acidic buffer. So in this case, the possibility is there that first case would be H3PO4 and NaH2PO4, the first possibility. The second possibility would be there. You have this NaH2PO4 because it has acidic proton. That's why I'm treating it as acid. And then Na2HPO4, the second type of buffer that can be formed here. Further, Na2HPO4 and here is Na3PO4. So only three possibilities are there, and that is why the total number of buffers those can be formed here would be 3, and that's why the correct answer is given in option 1. That is 3. Now, after this, it's a turn for question number 85. Question number 85. Which of the following set of salts will undergo anionic hydrolysis only? So if we talk about anionic hydrolysis, all those salts which are formed by the combination of a strong base and a weak acid will undergo anionic hydrolysis. So the salts of strong base and weak acid will undergo anionic hydrolysis. So let's check the options given here. In the given options, different salts are present. In the first option, we have 4 salts. We have to check. If all of them are the salt of strong base and weak acid, definitely that set contain all the salts which undergo anionic hydrolysis. Now let's check the options given here. In the first option, NaCl is given, the salt of strong acid and strong base. NH4Cl, the salt of strong acid and weak base. Acetic acid, salt of strong base and weak acid, while NaCN, salt of strong base and weak acid. It means this group is not following the condition. What was the condition? That all of these salt will undergo anionic hydrolysis. That condition is not followed in this case because NaCl is the salt of strong acid and strong base, and that's why it will not undergo anionic hydrolysis. Further, if we talk about ammonium chloride given in the second option, that is the salt of strong acid and weak base. It means in this case, this will not undergo anionic hydrolysis. Similarly, if we talk about KCN, this is the salt of strong base and weak acid. It can undergo anionic hydrolysis, but the second compound that's given here, that ammonium chloride, is not following. So whole set will not considered as that group that we have to choose as the correct option. I'm just going to discard it. Even if we talk about barium chloride, that is the salt of HCl and barium hydroxide. So in this case, again, the strong acid and weak base is there. It will not undergo anionic hydrolysis. So there is no need to read further. In the third option, there is HCOONA, sodium acetate, that's a salt of strong base and weak acid. It will undergo anionic hydrolysis. Further, CH3COOK, that is potassium acetate. This is a salt of strong base and weak acid, and it will undergo anionic hydrolysis. This is following this. Further, NaCN, this is the salt of strong base and weak acid. Again, it will undergo anionic hydrolysis. KCN, the salt of strong base and weak acid. This is also undergo anionic hydrolysis. And on that basis, this option contains all the salts which will undergo anionic hydrolysis. This can be the correct option, but let's check next one also. Now, in the fourth option, if you look here, the NH4Cl, ammonium acetate are given. Ammonium acetate, the salt of weak base and weak acid. It will not undergo anionic hydrolysis. Similarly, NH4Cl, the salt of ammonium hydroxide and HCl, it means it is also not undergoing anionic hydrolysis. So this cannot be the correct option. So where the correct option is there, we have already identified it. This is given in option 3, and that's why I'll choose it as the correct option. I hope this question is also clear to you. Let's move on to question number 86.